In this video, we're going to talk about how to calculate the probability of a binomial distribution. So here we have a problem where a 6-sided die is rolled 12 times. What is the probability of getting a 4 5 times? So here's the formula that we need. The probability of getting x successes is equal to the combination formula NCX, which can be written that way, times p raised to the x times q raised to the n minus x. So as we said before, capital P of x is the probability that there will be exactly x successes in n trials. Lowercase p is the probability of getting a successful event. Lowercase q is the probability that an event fails. So in this problem, we need to determine 4 things: n, x, lowercase p, and lowercase q. So what are the values of these 4 variables? What's n? N is the number of trials. The 6-sided die is rolled 12 times, so n is 12. Now, how many successful events are we getting in this problem? We want to get a 4 5 times. So we want to successfully get a 4 5 times. So there's 5 successful events that we're trying to achieve here. Now, what is the probability of getting a successful event? What is the probability of rolling a 4 using a 6-sided die? So out of the 6 numbers that we can get, there's only one successful number, which is a 4. So the probability of rolling a 4 is 1 out of 6, because it's one number out of the 6 numbers that we can get. Now let's calculate Q. What is the probability that the event will fail? What is the probability that we will not get a 4? Out of the 6 numbers that we can get, 5 of those numbers does not represent a 4. So the probability of not getting a 4 is going to be 5 out of 6. Now let's talk about how to calculate this portion of the equation. So we need to use the combination formula. Perhaps you've seen it. This is NCR, and that's going to equal n factorial divided by n minus r factorial times r factorial. So n is 12, x is 5. So this is 12c5. So that's going to equal 12 factorial divided by 12 minus 5 factorial, and then times r factorial, or 5 factorial. 12 factorial, that's going to be 12 times 11 times 10 times 9 all the way to 1 times 8 times 7 factorial. 7 factorial is basically 7 times 6 times 5 times 4 times 3 times 2 times 1. Now, 12 minus 5 is 7. So we can write that as 7 factorial. And note that we can cancel these two. 5 factorial, that's going to be 5 times 4 times 3 times 2 times 1. Now, 4 and 3, they multiply to 12, so we can cancel that with the 12 on top. 5 times 2 is 10. So what we have left over is 11 times 9 times 8. 11 times 9 is 99. 99 times 8 is 792. So this portion of the formula is equal to 792. So we have P of x, where x is 5. That's equal to 792 times lowercase p, which is 1 over 6, raised to the x power, or to the 5th power, times q, which is 5 over 6, raised to the n minus x, or 12 minus 5. So at this point, you can just plug this in to your calculator and get the answer. So just type it exactly the way you see it. And so you should get 0.028425. If we multiply that by 100%, we're going to get approximately 2.84%. So that's the probability of getting a 4 5 times if we roll a 6-sided die 12 times. Number 2, a multiple choice test contains 20 questions with answer choices A, B, C, and D. Only one answer choice to each question represents a correct answer. Find the probability that a student will answer exactly 6 questions correct if he makes random guesses on all 20 questions. So go ahead and take a minute and try this problem. So let's begin with the formula. So it's going to be NCX times the probability that it will be successful raised to the x power times the probability that it's going to fail raised to the n minus x. Now, what are the variables n, x, p, and q in this problem? So like before, n is the number of trials. In this case, the 20 questions. Now, how many of these 20 trials does the student have to get a successful event? He needs to answer exactly 6 questions correct out of the 20 questions. So there has to be 6 successes in 20 trials. Now, what are the values of P and Q? In this case, P is going to be the probability of getting a question right by randomly guessing an answer. So there's 4 answer choices, one of them is correct. So the probability is going to be 1 out of 4 or 0.25. Which means the probability of guessing the question wrong is going to be 3 out of 4 because there's only one correct answer, the other 3 are wrong. 3 out of 4 is basically 0.75. That's the probability that he will get the question wrong if he guesses randomly. So now that we have the values of n, x, p, and q, let's go ahead and calculate the value of NCX, or 20C6. This is going to be 20 factorial divided by 20 minus 6 factorial times 6 factorial. So that's 20 factorial over 20 minus 6 is 14, and then times 6 factorial. So 20 factorial is going to be 20 times 19 times 18, and we're going to keep going until we get to 14. But I'm going to leave it as 14 factorial. And then I'm going to expand 6 factorial. So we're going to do just like we did before in the previous problem. We're going to cancel 14 factorial. And let's see what else we can do. So 5 times 4 is 20. And 6 times 3, that's going to be 18. And then 16 divided by 2 is 8. So what we have now is 19 times 17 times 8 times 15. So if we multiply those 4 numbers, we're going to get 38,760. Now, let's calculate the probability of guessing 6 answers or 6 questions correct out of the 20 questions. So it's 20C6, which we got it to be 38,760, times P. P is 0.25, X is 6, times Q, which is 0.75, raised to the n minus x. That's 20 minus 6, which is 14. So go ahead and plug those numbers in. I made a mistake. I gotta retype everything. The answer I got is 0.1 0.168609. Multiplying that by 100, it's approximately 16.86%. So that's the probability of guessing 6 questions correct out of the 20 multiple choice question tests, assuming there's 4 answer choices. If there were 5 answer choices, P and Q will be different. If there were 5 answer choices, P would be 0.20, Q would be 0.80. It will be 1 out of 5 for P. Number 3, 25% of all students enrolled in high school XYZ are taking algebra. 30 students are chosen at random. Part A, find a probability that exactly 7 students out of the 30 chosen are taking algebra. Go ahead and work on this problem. So we're going to use the same formula as we've been using in the last 2 problems. So what is n in this problem? N is going to be the number of students that are chosen at random. That's 30. X is going to be the number of successes in n trials. So these are going to be the number of students who are taking algebra out of the 30 chosen. So X is going to be 7. P is the probability of selecting a student who is taking algebra, and that's going to be 25% or 0.25. The probability of selecting a student who is not taking algebra, that's going to be Q, which is 1 minus P, which is 1 minus 0.25, and that's 0.75. So now we have everything that we need to answer part A. So we need to calculate P of 7. So this is going to be 30 and 7 times 0.25 raised to the 7th power times 0.75 raised to the 30 minus 7 power. So at this point, you know how to use the combination formula to calculate 30C7. So I'm just going to use my calculator to get this answer. 30C7, that is a huge number. It's 2,035,800. We're going to multiply that by 0.25 raised to the 7 times 0.75 raised to the 23rd power. So the answer is going to be 0.166236. If we multiply that by 100%, the answer is approximately 16.6%. So that is the probability of selecting exactly 7 students out of 30 who are taking algebra and who are enrolled in this school. Now go ahead and try part B. Feel free to pause the video and work on that example. What is the probability that fewer than 5 students out of the 30 who are selected are taking algebra? So now we're not dealing with just one number, but a range of values for x. So x has to be less than 5, which means it can be 1, it can be 2, 3, or 4, but not 5. It's not less than or equal to 5, it's just less than 5. So what we're going to have to do is calculate the probability when x is 1, 2, 3, and 4, and then add them up in order to get this answer. So let's find the probability that exactly 1 student out of the 30 is chosen at random who is taking algebra. So n is going to be 30, x is 1, p is still the same, it's 0.25. So it's 0.25 raised to the x is 1, q is the same, 0.75 raised to the n minus x, or 30 minus 1, which is 29. So this is going to be 30 C1, hopefully you have a calculator that can do that, times 0.25 times 0.75 raised to the 29th power. And so you should get 0.00178858. Multiplying that by 100, this is approximately 0.1786%. Now, let's calculate the probability that out of the 30 students who are chosen, exactly 2 are taking algebra. So this is going to be 30C2 times 0.25 raised to the second power times 0.75 raised to 30 minus 2, or to the 28th power. So the answer I got for this is 0.00866315, which is approximately 0.8631%. Well, this should be 46. So I'm going to round it to 0.8631. Now, let's calculate P of 3 using the same process. 30 minus 3 is 27. So it's 30C3 times 0.25 raised to the third power times 0.75 raised to the 27th power. And this is going to be 0.02685, which is 2.685%. Now, let's calculate P of 4. So it's 30C4 times 0.25 to the fourth power times 0.75 to the 26th power. So this comes out to 0.06042. So that's going to be 6.042%. So now what we're going to do is add these 4 values to get our final answer. So the probability of getting fewer than 5 students who are taking algebra out of the 30 chosen, that's going to be approximately 9.769%. So if you have an inequality, such as fewer than 5, you need to calculate multiple values in this case. So you have to calculate the probability of getting 1, 2, 3, or 4 students out of the 30 who are taking algebra. As you can see, this could be a long repetitive process, and if n is very large, you could use the normal distribution to approximate a binomial distribution. But for this particular example, since we only have to calculate 4, I just decided to add all 4 values. Now, let's move on to part C, the final part in this video. So how can we calculate the mean and the standard deviation of this binomial distribution? How can we do that? The mean is going to equal the number of trials times the probability of getting a successful event. N in this case is 30. We know that P is 0.25. So it's 30 times 0.25, which is 7.5. So as you can see, it's very easy to calculate the mean if you know N and P, which is given to you in the problem. Now, to calculate the standard deviation, it's not that difficult either. It's the square root of N times P times Q. N is 30, P is 0.25, Q is 0.75. Now let's go ahead and plug this in. So the answer I got for the standard deviation is 2.3717. So that's how you can calculate the mean and the standard deviation of a binomial distribution. So that's it for this video. Don't forget to subscribe to this channel if you haven't done so already. And thanks again for watching.